Hello everybody, my name is Craig Bennett and I'm the founder and owner of TechFuseNope, and today I am going to do another CCNA class, and in this class we're going to get into protocols. And what protocols do is simply it's just a way for things to talk to other things and how they talk to other things. So one thing I want to mention before we jump on in is good portions of what I'm going to be talking about. It has something to do with security, but it's going to be very, very vague in this video because in the CCNA it's not that heavy in this type of security, or at least the hacking, like actually having to know how to purely break and use the security. There's a little bit of security stuff in the CCNA though. But one thing I want to mention is if you do want to learn more about the security side of these protocols in great depth, I do have quite a few videos on how to break some of these protocols and how to properly use some of these protocols in order to either find holes in the system that you're making, or maybe how to secure your network so at that time no one can break it. Keep in mind, over time new things come up. But anyways, and you can find those videos in the hacking playlist. There's quite a few of them in there. But anyways, let's jump into a quick personal advertisement so you guys know how to support my channel, and that way you can help it grow much faster and quicker than I can do just on my own. If you would like to support us at TechFuseNope, then please do one or all of the following. What you can do is you can select the TechFuseNope logo at the top, and this will take you to our TechFuseNope YouTube page, or you can select the PayPal button, and that will take you to our PayPal donation page, or you can select the Patreon campaign button, and that'll take you to our Patreon campaign. Now, saying that if you don't have the financial means, or you already done that, or whatever it may be, and you don't want to do that but you still want to support us, you can also do some of the following. You can leave a like and share this video and any other video that you want from us, and maybe even our channel, and tell people why you like us so other people could come and enjoy this and also help build up this community. You can also, if you like to help us but you dislike a certain video for whatever reason, go ahead and leave a dislike, but tell us what you don't like about it so we can fix it in the future. And also, as always, please feel free to subscribe and check out our other videos. And when you're checking out our videos, if you really want to support us, just go ahead and drop the ad blockers, and that way we can get our revenue. But if you want to continue to use your ad blockers, then feel free to do so. It's not like I'm not doing it. Welcome back. Now, some of this video is going to be PowerPoint based, but I'm trying to get the information across as best and clear as possible. So let's jump on in. What you will notice is a lot of time that you want to go on websites, you're dealing with HTTP or HTTPS. And a lot of people will realize that, but they don't know the difference. The biggest thing that you got to keep in mind is HTTPS is secure. It encrypts the data. Basically what happens, and I'm not going to try to get too deep, but basically what happens is the information is encrypted on whatever device you're on. It goes out through the network, it lands on the other device, the server or whatever, and then it decrypts from there, and it can read it. Now this is what I call a level 2 encryption, a level 2 security. It has nothing to do with CCNA, but it's very important to note that basically this is going beyond just making sure that you're not giving your password out or anything like that. You're not downloading anything that you don't know or anything like that. So HTTPS is something very, very important if you're going on for Gmails, banks, stuff like that. But knowing HTTP and HTTPS, the difference between there is very important. So with HTTP, it's very important for CCNA. HTTP is basically a plain text that comes across. If you want to know more about that, again, I got videos on that. Check out the Wireshark videos. So transfer files. This is very interesting and very useful. You'll see it a lot if you do any website design or website development, but you'll see it in other areas. FTP, File Transfer Protocol. It's as it sounds. It transfers files from one device to the next using FTP, and you can actually do it from one computer to another computer on the same network. I've used it on my own home network, and it's very useful, but you need to have certain ports open, and you need to have an interface that allows you to do it. SFTP, it is a secure file transfer protocol. So file transfer protocol, like HTTP, is unencrypted. It's plain text. It's easy to read. It's you'll see file transfer protocol just a plain more than not, especially in secure environments. But SFTP, you're going to see that a lot when you're dealing with government systems, dealing with business systems, and some others, that things really do need to be secured coming across. Now, TFTP is unsecured, unencrypted, but it's trivial file transfer protocol. As the name suggests, it's for very, very small files, 1 file or 2 files, things like that. You probably won't deal with that much, but it's very important to note for the CCNA. But you're probably going to see more of the SFTP or the FTP. Now, with email, there's email protocols, and you might have to deal with this, especially if you deal with Outlook. And we now use HTTPS like Gmail and WebDave, but with back in the day, we had email before we had actual browsers. 92, 93, first browsers came out, side note. But we have POP3, IMAP, and SMTP. Now, one of the differences is with SMTP and the POP3 and IMAP. I'm going to get a little bit more into this later, but SMTP is send messages out. The other two is mostly for receiving. You'll see SMTP really come up heavily in some devices or some software where it only sends messages out and it doesn't receive it. Antivirus software is an example of this, because you don't need the antivirus software to get a message, because there's no way to read it off the antivirus itself. But if you get a virus on, say, a server, you need to set up something so you get an email saying, hey, there's a potential security threat, so you can look at it. But it takes that in order for that to happen. Now, as far as the remote device access, you have Telnet and SSH. Telnet is unencrypted. SSH is encrypted. It's very hard to break the SSH. Again, I got videos on this and the hacking stuff on the encryption, but that's the thing that you gotta keep in mind. And then we got remote desktop connection. Now, as far as remote desktop connection, I won't worry too much about that, but for those of you who don't know what it is, it's basically a Microsoft thing. I wouldn't worry too much about it with CCNA. But basically it allows you access to, well, a desktop remotely. as the name suggests. But as far as things goes, we have the DNS, which is very important. It's basically like a phone book. So what you have on Google, whenever you go on, say, Google or whatever, then what you have is a bunch of websites that come up whenever you search for something. Well, in order to get from one place to the next, or even just get to Google, you have to use a DNS. Basically, what happens is the DNS associates whatever website name with the public IP address, and that way, instead you have to type in the IP address for each and everything, because people can't really remember numbers as much as, you know, words. Like, if you can remember something like, I don't know, 387.241 6743 blah blah, and then remember 1,000 other websites, because how many websites do you visit on a daily basis? How many websites do you visit on a monthly basis? How many websites do you visit on a yearly basis? It's a lot. It's a very lot. And with that in mind is, can you really remember all those IP addresses if they're static? That's a huge thing. If they're not static, then you're kind of out of luck, because you're gonna have to find up all the IP addresses for all the websites in order to connect to them. But one thing I will mention is the DNS, while it allows all you have to do is type in, say, google.com or yahoo.com or whatever it may be, and it knows the associated IP address, so it just takes you to the website instead of you having to type in the IP address. Some governments during wartime, and you'll see it mostly in the Middle East, where you probably see it all over the world at one point or another, but you'll see it where they will block the website so their own people can't communicate out to ask for help, or the rebels cannot communicate to one another as easy. So one way around that is by just putting in the IP address, because a lot of the time what you'll find, especially in Middle East, where it's war torn, they don't have the money, they don't have the time, and they really can't get anyone in there that feels safe enough in order to actually sit there and say, we need to block both and then some. They're probably just going to block the, say, google.com, where the person can, if they know the IP address, they can type it in, the HTTPS or HTTP / and IP address, and then there you go, you can get into it. It's very important to note this. Now, an example of this is, now with using my websites, what I'm going to do is I'm going to just use this as an example on what will happen if we didn't have a DNS out there. What you can do is, if you have, say, Chrome or Internet Explorer or Firefox, and outside of this video, make sure you keep this video up, go pull up a browser tab and just put the following IP address in: 74.125.22. Or sorry about that, 224.72. So 74.125.224.72. At this time, it might, and most likely these the IP address will stay static, since this is a Google's IP address. But if it's not a static deal, like I suspect it is, then this IP address might actually link you somewhere else. So be careful. But what you can do is you can put HTTP, so the protocol, / and press enter, and it will take you to Google's page, because this is their IP address. It just basically links to their server. So that's a huge thing to keep in mind, is this, because without DNS we pretty much will have to remember every single website. And can you imagine how many websites you'll miss, or how many times you'll mess up? And it only takes one mess up to get a security failure, because if you go to a website, you actually download that web page, and the thing is there might be something bad if you go to the wrong one. Now, going back on topic, this is very important, especially for the CCNA and a potential job. It's known as Internet Engineering Task Force, or known as IETF. You can search it up, IETF.org, and they hold all the RFCs, and you can actually see this over here on the RFC page. And as this says here, it pretty much tells you pretty much all the stuff, but it's a request for comments. Now, as far as why this is important notes, back in the day, pretty much all the engineers, they needed a way to communicate with one another in, very remote areas. Well, one way to do it is have a pure database of the protocols and information about them, and that's where this request for comments comes in place. And it's very important because new protocols and current ones, they will be stored here, and any changes, anything like that, they will be stored here. And I will have a link below the video in the descriptions, so you can check it out, you can play with it, and you get to know the stuff. It's very important for the CCNA. So if you're wondering about the stuff, just go to the RFC search page, and what we want to do is, we don't know the number, but let's say something like HTTP, and then click search, and let's see if it acts right. And as you see here, this is all the stuff related to the keyword HTTP. But anyways, what you can do with this is you can take a look at the number, and let's just click on one to open it up, and you can get the basic information about it. You can get the status, the authors, and several other things, and for the definition and so on. Let's try to find one that has a little bit more. So just looking at the newest ones out there, and as you see here, it's January 2015, and we got some of the newest ones all the way up to, if you look at these, October 2014, but for here, what we're looking at is in June 2014. So it's still being worked on even till today. As you saw, it's going all the way back in the 90s. Still being worked on today. Click on one, and as you see here, what it replaced, what's replaced it, proposed standard, and so on and so on. And if you wanted to know more about a particular one, you can just select the right here, the URL, and this will tell you everything about that protocol. Now, you don't need to know all this. You don't need to know all the little finite details. The only individuals that need to know all these things and have to regularly review it is ones who work on browsers. Some applications, not many of them do it at all. I make applications on both computers and mobile devices, and I don't really even look at this at all. But if you're going to make an operating system, then you might want to look into this, because some of the newer operating systems, they're integrated into the actual functions, maybe the search function, maybe some other stuff. You'll see this in Ubuntu, the Windows 10 that's coming out soon. You'll see that, and with Android and iOS, you definitely see this, and that's one of the reasons why I personally don't have to deal with it when I make Android applications. But if you're making a browser, then you regularly have to look at this, because what happens is the RFC is a database of almost all, if not all, of the protocols out there, the internet-based protocols, which is very important, because what happens when you go from, say, Chrome to Firefox? Why does it work when I go from Chrome and go to Firefox? If I type in my website, techfusionup.com, why doesn't it take me to, say, Google on one thing, and then take me to eBay on the other, and then on another one it takes me to the website I want to go to? It's because they all use the RFCs in order to basically make it where you can go to the website that you want, no matter which browser you want to go to. And keep in mind, while there is competition between the browsers themselves, if they go outside of this, then they become useless and they become obsolete very quickly. That's why you're going to have it where it's universally they're going to use the same protocols. Now, how quickly they update these protocols is another story, and how they use the protocols is also another story, and how much convenience they take off of you is again another one. Because back in the day, you had to type in, even today you can get pretty close on typing in something and the thing will do it for you for the most part. But back in the day, you had to type in every little thing. And even if you, say for example, want to look up a, I don't know, say for example, on my router, my internal router is 192.168.1.1, the IP address. If I want to communicate to the router and do some maintenance on it, then on Internet Explorer, even to today, I got to put the HTTP in front of it, and if I don't do it, then the convenience is not there, whereas I can go in Firefox and Chrome and the convenience is there. But either case, once that HTTP is in front of it, whereas Google Chrome and Firefox will automatically put it in front of it, it treats the protocol the same across the board. And an example of a FTP server is this. I already got a FTP server on my own local network. You can get a free FTP server, at least software-wise, by just getting FileZilla. I might make a video on how to set that up later. But as far as that goes, you just need a computer that you're willing to sacrifice as a server, or at least once in a while use as a server. And on the other computer, what you can do is go to the start and type in CMD, and this will open up command prompt. You don't need administrator passwords or administrator rights to this, and you simply just type in FTP and whatever the server is. So mine is 192.168.1.8, and give it a second or two and it will connect. And from here it's asking me for the username and password and all the other stuff, and we don't want that, so there you go. So just disconnected from the thing. But anyway, that's a example of FTP server. Another one is the FileZilla software itself, and this is what you're probably more going to commonly see. So as you see right here, we have a the actual thing up here, and then you got the login, username, and password. The port by default is 21. That's the FTP port. You can change that on any FTP server. You can change that, unless if you're renting out space on a FTP server, then you have to use whatever they have. For example, GoDaddy. Now, as far as this right here, this, and I'll probably get into another video into this on how to set this up, but this basically shows you what's going on. Below here shows you your computer, that server or its computer, and you can just transfer files like that over the network, and it's pretty easy, and I prefer to do it in some cases. Now, as far as the secure protocol and the trivial, the secure protocol is pretty much the same as the FTP, as you saw, except for it's secured. There's a little bit more setting up to do, but pretty much generally the same. And on the server side, on some of the server software, not all of them do this, but on some of the server software, and FileZilla does this, you can actually set up where when a user logs in, they only can log in through the secure stuff. So you can take care of it through that. Now the trivial, it's just a different port, but it's pretty much the same as far as what you saw. Now, under the remote access part, I'm skipping over the email because most people already know that, but the biggest thing that you got to take away from that is that is some of the ports. Now the exacts of it, you might get tested on some of the exacts, but for the most part, and this is talking to people who work out in Cisco, that's not a huge thing to look for. However, knowing that it's there is important, and that part will be on the test, or it should be. Now, as far as the remote access, and this is pretty important because we're going to get into this more and more and more as we go on with these classes. And if you look at some of my packet tracers, the actual videos done with packet tracer, you'll see it really hardcore right there. So as far as what we're looking at, packet tracer, which is a simulator for networks, it's a lot cheaper. It's free for me, but it's a lot cheaper than buying $4,000 worth of equipment, just to show you guys something and just to play with for a short amount of time. But anyways, so as far as things goes, we got a computer, a desktop, and a switch. This blue line is a console cable. So as you see here, it's plugged in. We try to plug it into whatever we can do it, but it's not a good thing. And that's the same way in real life. It's highly advised to, in fact, I would say it's mandatory to never plug a console cable into an Ethernet cable, even in real life. More so in real life. You can tear up equipment. I'll get into later what is the difference between the cables, because there's a huge difference, and the problem is they could potentially look the same. I haven't seen that problem, but the ends are the same, and it could potentially be a huge problem, especially if you're going through it real fast. You don't really notice it. Oh, I shouldn't have done that you'll run into that type of moment. I have done it myself. Pretty sure most people have, but you can really mess up something if you don't watch it. But anyways, outside again, I'm getting to another day. So this example, let's open up this and go into terminal. And in real life, you'll open up a program called Putty. You have to download it from the internet. And as you see here, I already changed the name of the switch, just playing around. And I think it was, so as you see here, just changed it again. And now I'm back to square one. So basically I just modified part of the switch, and this is what you're going to deal with more than less when it comes to servers. Not all servers, but more than less switches and routers and things like that. Now with some of this stuff, there is actual GUIs, GUI, graphical user interface, but at this time, and I believe this is going to change in the future, you're seeing a lot of pushback from people who's been in this stuff for years and years and years and years. They really don't want to go into graphical user interface, and what it's been before, especially in the Windows servers, up till the Windows 2012, I think, you had a choice of either the graphical user interface or the console line. Now they have it where you can go to either the graphical user interface or the console line. I mean, you can switch back and forth with a snap of a finger. Before, you had to format the entire system just to get the other version. Some of the things, I'm seeing it going towards the graphical user interface. That's one reason why you see a push for the terminal, the command line. And the other reason is it's still currently, you can do more with the command line than you can with the graphical interface. The thing with the graphical interface is, again, I think one day we're going to get to the point where they're going to be equivalent, but I think you're still going to see a pushback until these not hurt anyone's feelings, but the older crowd dies out or retires, and I think that's going to be several generations of IT. So that's pretty important to note. So if you're watching this and everything, given it's anywhere between 2015 to 2020, then you're probably still going to have to do the command line, unfortunately. But if you do it on your own systems, you know, do whatever. I'll suggest doing the command line when possible, because it's good practice. A lot of people, I see them run in situations where they just don't know what to do. They get a chance to play with the switches, routers, and whatever, but they flat out just don't know the commands. And of course, you're not supposed to know every command. So for example, I can go, I don't know if I can do it at this level. Yeah, I can. So basically I just set a question mark and it tells me everything I can do. And as you see here, and everything isn't listed on that, so it's actual. It's also pretty important. I don't see a right mem. No, I do. It's right here. So that's pretty important. In fact, just get into that real quick. The right mem, and I know this is a little off topic for this video, but this is pretty important for the CCNA. Is some of the commands are not going to be on here, or a modified version of the command will be on here. So for example, I can hit write. Also I can do WRIMEM. I can do W, and those three things does the exact same command. So that's a pretty important thing. Huh, I didn't spell. that one right first time. But I mean, that show you it does the exact same command, and that's pretty important to note that not all the commands are on that list. And furthermore, some of the commands they can be written a different way. So that's pretty important. Now, the last little bit, we're going to get into the DNS, and this is probably one of the more important things. I'm also going to make a separate video pretty much reiterating what I'm saying here, because it'll be quite useful for people who's in third world countries and also war zones. So as far as things goes, we're going to be using command prompt. You can be using terminal if you're on OS X or Linux. So let's open up the start menu and put in CMD and press enter. And one thing I want to mention is there's going to be quite a few things that are going to be blocked out, so keep that in mind. So as far as this, what we want to put in is something that connects us to our local DNS server. I don't have one at my house, so we're going to connect to La La Land. I don't know where it is. And this NS lookup, all one thing. Again, I'll make another video on this, so the code will be on the other videos. But go in and type in a website address. It could include a www, but you don't have to. So with this, it's tech reviews and help.com, and as you see here, it just pulled back and it said the IP address to the website is this. Now what happens if you are in a war zone, just real quick, or in some country that wants to block certain things, it'll block that, or it might just take the whole thing and block it. But usually what will happen is the civilians or the rebels, depending on the area, they will have to connect in through a DNS server inside the country, whatever the government controls, or the rebels, depending on who's doing what in the wartime. And what will happen is they'll just take that off, and you can still access the websites 90% of the time, because they don't really know how to actually really block something. But you can't look up the IP address. That's the problem. So if you want to look it up, the DNS server doesn't know it, and there's potential it's blocked, so it can't find it. So as far as that goes, that's something to keep in mind. But now let's try something like Google. And as you see here, now we got multiple things. So as far as this goes, whereas the TechFuse Help site only has one IP address, we have multiple IP addresses for Google. Why is that? Google has a redundancy into its IP addresses, so if one fails, then the one pick up, and so on and so on. And you might notice that this is different from what I used in the first example, and the reason for that is these are what's closer to me, the closest to me, so I can get it very timely in their service. Now, the way to think about this is like phone numbers. So you dial up the phone number and you can contact someone if they're there. And I got one phone number, or in this case one IP address. Google has multiple phone numbers, which you'll probably see with in multiple ways to contact them. But in the real world, it'll be like work phone, home phone, yada yada. But in all cases, it's just a number to get to the servers. So if you went into a browser, put in HTTP blah blah, and put in these numbers on one of these lines, it will take you to Google. At least at this time it will. And it will take you to my site. At this time it will. Now, if a website only has one IP address, it doesn't mean that's good, it doesn't mean that's bad, it doesn't mean anything other than if that IP address fails, then you can get to it. However, it's possible, and I have it on mine, so I don't need multiple IP addresses. However, Google is a big company, so they can do it like this, and they can spend the money where I can't. If my IP address fails, a short time later, another IP address will kick up in place, and there's a little bit of load balancing and all the other stuff. This is definitely not a class to talk about that, so I'm just going to pass that by. But I'm saying that if a website has only one IP address, it doesn't mean it's good, it doesn't mean it's bad, it doesn't mean anything other than if the IP address fails, then you can't communicate with it. It's like if you want to call up someone, their phone number fails, you can't call them. But if they got multiple phones, if one phone number went down, well, you can still try the others, and you can probably get a hold of them, as like this. Oh, and before I forget, one of the things you might find is, and my site doesn't have IP version 6. I didn't enable it since like no one uses it, at least right now. But as far as this goes, you might notice that this long odd number, it is IPv6, IP version 6. That's pretty much what it looks like. Below here is IPv4, and that's pretty important to note, because this is IPv6. If it went out, then that's that. And you might notice how important it is due to that Google having one, but having like quite a few IPv4s. So that tells you a lot right there. One thing I will tell you is a lot of network people there are like, yeah, it's going to happen in X amount of time, but I'm going to tell you right now, it's probably not going to happen for a long time before you see all devices purely use IPv6. One of the reasons why I think you're really never going to see it, you're eventually going to see it, where devices, pretty much all devices, had the ability to use IPv6, but you're probably never going to actually see it fully and use like it should be, because even, I mean, I can't remember all that. Not many people can. I can remember this, a couple sets of numbers, but I can't remember an entire IPv6. So yeah, and I mean, you look at your local network in your own house, most of your devices probably could support IPv6, but can you imagine trying to remember 12 or so different devices just for your house? And then if you work as an actual network administrator, which is what you should be aiming for a CCNA, then you're probably going to have to remember a lot more than that. So that's a huge thing to keep in mind. And that's when anyone says IPv6 is going to happen soon. You know, I wouldn't say much, but I mean, you know, just say good luck, man, because it ain't going to happen anytime soon. It's probably going to happen one day, though. Now, another thing I want to add is, before I forget, it's not that hard. It's pretty similar on how to set them up. It's just that the hashes, I mean, it's just a pain to remember. But other than that, it's pretty similar to set it up. In fact, it's actually easier to set up a IPv6 than a IPv4 for subnetting. For home network, it's pretty much the same, and small business is the same. But if you're going for an actual business, like of actual size, where you have several thousand devices, then what you're going to end up having to do is some type of IPv6, and that will save you a bunch of time right there. And I can tell you, it's like night and day on how easier it is. But for home devices, small businesses, and we're talking about businesses less than 100 devices, it's like, so what? But it is important to know for the CCNA. Now that's pretty much all I'm going to cover in this particular video. And if you got any questions, feel free to leave them down there in the comment section, or if you got a comment or a tip or whatever, go ahead and leave that in the comment section too. But as far as things goes, hope that this hasn't overloaded you, and hope that this has been fairly interested. I tried to put all the information that you need to know in the PowerPoint section at the front, and then just got into some real world examples, or real-ish at times, and hopefully that's helped you out. But as far as things goes, if you felt like I skipped over something, or if you need something a little bit more clarified, feel free to ask, and I'll try to help you guys out, because right now I'm studying for the CCNA, but I kind of know what I'm talking about, so I'm talking a little bit more higher level than I should be. But anyways, this has been Creepman, the founder of Tech Fusenel. Please leave a like, please subscribe, and please share if you like this. If you didn't like it, then feel free to leave a dislike, but tell me why, and that way I can fix it in future videos. But if you like this, please feel free to check out our other videos, and also the Patreon campaign and PayPal link in the techfusenel.com. Hope you have a great day.